Okay, so let's start. So we are going to talk about some elements of group 3. Sorry, we are talking about some elements today of period 3, right? And we are going to talk about the reactions of these elements present in period 3 of the periodic table, right? So first of all, I'm going to start with sodium, right? I'm going to start with sodium. So right now, we are going to talk about sodium, which is the element of period 3, right, Bishop? So first of all, initially, we are just going to talk about the reactions of sodium. Yes, reaction of sodium. Okay, so reaction of sodium with oxygen, right? अगर आपके पास सोडियम का रिएक्शन होता है, reaction with oxygen. अगर आपके पास ऑक्सीजन के साथ सोडियम का रिएक्शन होता है, so क्या होता है, ऐसा क्या होता है आपके पास रिएक्शन के दौरान, क्योंकि हमें पता होना चाहिए. And this is actually whenever you are going to react sodium with oxygen, it is going to do like this. Sodium is going to react with oxygen, form sodium oxide. We know that sodium is from group number 1, so it is +1, and oxygen from group number 6, so it is -2. So this 2 here and this 1 is here. So the formula between these two elements is sodium oxide, right? So whenever sodium burns in the presence of oxygen, it is going to form sodium oxide. It is not only for sodium. Whatever the element, when it burns in the presence of oxygen, the oxygen is going to react with that element and attach in the form of oxide, right? So this is the reaction of sodium with oxygen. Then what happens when you put sodium into the water, right? So what is the reaction of sodium with water? If you react sodium with water, what is the reaction? If you remember in O levels, you did that, right? Whenever you put sodium or any group 1 metal into the water, in even cold water, right? They can react react with cold water as well, right? इतने ज़्यादा reactive के cold water से भी reaction कर सकते हैं. So if you put sodium into the cold water or the normal water, so they are going to react, right? And always they are going to form the hydroxides, right? They are going to form the hydroxide plus hydrogen gas. So the charge of hydroxide is -1, and the charge on group 1 metals is what? +1. When they combine, they're just going to form like this, right? When the charges are opposite, the number are same, we just combine them together, right? So this is right now sodium, so it will be sodium hydroxide plus hydrogen gas is mandatory, right? So when we are going to balance this, so right now we need to write 2 over here, so we have even number of hydrogens, 4 hydrogens over here on the right hand side, so we need to write 2 over here, so hydrogen is balanced on both sides. Then we have 2 sodium, so we need to write 2 over here as well, right? So this is balanced equation with water. Right now, the reaction with halogen as well. There is a reaction with halogen as well. So reaction with halogen. What happens when sodium is going to react with halogens? Halogens are group 7 metals or group 7 non-metals, right? तो ग्रुप 7 के जो नॉन मेटल्स होते हैं उनको हैलोजेंस आप बोलते हैं. उनका जब रिएक्शन होता है सोडियम के साथ तो क्या होगा? It's very simple. So whenever sodium reacts with, for example, chlorine, so ये बात जब chlorine के साथ react करेगा तो sodium is group 1 element, so it is +1, and chlorine is group 7, so it is -1. When the charges are opposite and the number are same, we just combine them together, so it will form salt. Right now we have 2 chlorine on the left hand side, so we can write 2 over here and 2 over here. So it is a balanced equation, right? So these are actually the reaction of sodium with oxygen, water, and halogens. ठीक है. अब इसकी ऑब्जर्वेशंस भी आपको पता होना चाहिए. किसी भी रिएक्शन की ऑब्जर्वेशन आप किस तरह लिख सकते हैं आपको पता होना चाहिए. Now, if you are from IGCSE, so you need to remember that जब भी आप सोडियम को बर्न करते हो तो उसके फ्लेम का कलर जो आता है वो ऑरेंज फ्लेम शो करता है, ठीक है ना? So you can say that orange flame is one of the observation of this reaction. Orange flame, right? Orange flame. Or sodium oxide is actually white crystalline solid. You can even say that white solid forms. White solid forms. So you can write the observations of this reaction like this, and talk about this one. So this reaction has multiple observations, right? First of all, you can see this over here. We have one of the product which is gaseous, right? So you can even write observation over here. आप इसकी एक observation तो बच्चों ये लिख सकते हो कि क्या observation आप लिख सकते हैं, colorless gas. This is right. एक तो आप observation भी लिख सकते हैं. Then you can see over here one of the reactant is solid and there is no solid in the product. So one of the observation that you can write over here is बच्चों, you can write that solid जो आपने ऐड किया होगा, it is going to disappear. Solid disappears. You can even write this as well. और उसके अलावा अगर आप लिखना चाहें तो आप लिख सकते हैं ग्रुप 1 के बारे में. आप पता होना चाहिए कि they have low density and even they have the low density than water. Okay, so you can even say that they can float on the surface of water. Float on the surface of water. First they float and they are going to react, right? Float on the surface of water, or it is actually exothermic reactions. If you want to write heat releases, so you can even write like this. Okay, heat releases. Okay, so these are actually the observations for this reaction, right? Then what about this one, the last one? You can say that we know that sodium chloride is white solid, so you can say that white solid forms. That is the only observation for this reaction, white solid forms, right? So these are the observations of these three reactions. You need to remember about these three reactions. Is that right, Vachon?
Yes, sir.
If you talk about sodium oxide, if you talk about sodium oxide, we are just talking about right now sodium oxide. अगर आप sodium oxide की बात करते हो बच्चों, तो sodium oxide is actually what? Sodium oxide is actually giant ionic lattice. This is actually what? Giant ionic lattice, right? क्योंकि ये ionic compound है तो ये कहलाएगा giant ionic lattice, right? And it is basic as well, right? So it is basic in nature. It is basic in nature. So when all metal oxides are basic except aluminum and zinc and lead, so this is basic in nature, right? So when it is basic, so definitely it can react with acids as well. So when it reacts with acid, so it will give you salt and water. So this is basic oxide. When react with acid, definitely give you salt. This is a thing that you need to remember. And you can also write over here, this is that sodium oxide. You need to remember this, that all the oxides are insoluble in water except potassium oxide and sodium oxide. The metal oxides are insoluble in water except sodium and potassium oxide. So sodium oxide is actually soluble in water. It is actually soluble in water, right? So you can write this one as well, and it gives alkaline solution. It gives alkaline solution when dissolved in water, right? So we can write the reaction over here as well. When sodium oxide dissolved in water, it will give you highly strong alkaline solution, which is sodium hydroxide, right? This reaction is again exothermic reaction, and the pH will be there to almost 13 to 14, right? But is that right, Bacho?
Yes, sir.
If you talk about NaCl over here, so NaCl is also what? It is also giant ionic lattice because it is also ionic compound. So it is also giant ionic lattice, right? This is the structure over here. And then NaCl can dissolve in water and give you neutral solution. So it is also soluble in water, right? And will give you neutral solution. Neutral solution, right? And if you talk about the equation, so this is actually dissociation equation. So when you dissolve any ion compound, it dissociate into aqueous ions, right? So this will be aqueous, this will be aqueous, right? And the pH will be near 7, and the solution is colorless, right? So you all need to remember this about sodium, right? So this is sodium, right? So you can take a picture of this. So can we move on? Can we move on?
Yes, sir.
Okay, so now let's talk about magnesium, the second member of the period 3, magnesium, right? If you talk about magnesium, so again, let's talk about the reaction with the following species, right? So the first one is reaction with oxygen. So the reaction with oxygen. Okay, so when again यहाँ पर भी जब आपके पास स्टार्ट होगा, फॉर एग्जांपल रिएक्शन मैग्नीशियम बर्न कर रहे हैं आप ऑक्सीजन के प्रेजेंस में, तो यहाँ पर भी क्या बनेगा आपके पास, ऑक्साइड ही बनेगा, ठीक है। यहाँ पर भी आपके पास क्या बनेगा बच्चों, ऑक्साइड ही बनेगा। फॉर एग्जांपल इफ यू बर्न मैग्नीशियम इन द प्रेजेंस ऑफ oxygen, so what is going to be happen, magnesium reacts with oxygen and it is also going to form oxide of magnesium, right? And we know that magnesium is actually 2 plus and oxygen is actually 2 minus, so the charges are opposite and the numbers are same, so we just combine them together, right? Right, bachcho?
Yes, sir.
Okay, then we can balance this as well. If you want to balance this, so we have 2 oxygen on the left hand side, so we can write 2 over here and 2 over here. So this is going to be balanced over here. If you talk about the observations, the observation is I think a very common of this reaction. You all know this, that if you are going to burn magnesium in the presence of oxygen, so it will show you a bright white flame. आप लोगों ने स्कूल लैब में लाजमी ये वाला रिएक्शन देखा होगा, जब भी आप मैग्नीशियम रिबन को बर्न करते हो, so it will give you bright flame, bright white flame, right? So you can say that burns with bright white flame, right? This is one of the observation and which is very common in school labs. आजकल हर टीचर ये रिएक्शंस कराता है, लाजमी क्योंकि बहुत ही थोड़ा सा मजे का रिएक्शन होता है, बच्चे खुश होते हैं इसको देख के ना। So second one is magnesium oxide is actually white powder, so you can say that white solid is formed, white solid forms, and ये जो magnesium oxide होता है ना बच्चों, ये it is just like the ash, ये ash की तरह होता है, ठीक है? So it will going to be formed. Then let's talk about the reaction with water. If you react magnesium with water, so again the same reaction happen like we did with sodium, right? तो यहाँ पर भी आपके पास क्या होगा, it is going to form the hydroxide plus hydrogen gas, right? So whenever magnesium also reacts with water, it will give you the magnesium hydroxide and hydrogen gas and hydrogen gas. And if you want to balance this, that's quite simple. We can write 2 over here for the balancing, right? But you need to keep remember this reaction is actually very slow reaction. This is very slow reaction. So it's not a very common reaction or very quick reaction, right? So it is very slow reaction. So अगर आप इसका reaction कराएंगे, for example, ठंडे पानी, बहुत ठंडे पानी, रिएक्शन स्लो होगा. अगर आप इसका रिएक्शन क्विक कराना चाहते हैं, so you need to provide heat over there, and the heat is only you can say that you can use warm water over here, or you can use steam over here as well. So it will be quick when you are using hot water or steam. Otherwise, if you are using a cold water, so over here the reaction will be slower, right? For example, आप ये reaction ले रहे हैं steam के साथ, तो क्या होगा? If you are doing a reaction with steam, so it will be like यहाँ पर आपके पास सोडियम हाइड्रोक्साइड नहीं बनेगा, फिर स्टीम के साथ क्या बन जाएगा आपके पास, फिर एक छोटा सा चेंज आएगा, एंड द छोटा सा चेंज इज दिस कि आपके पास मैग्नीशियम हाइड्रोक्साइड की जगह मैग्नीशियम ऑक्साइड बन जाएगा. बट द रिएक्शन इज ओवर देयर एंड इट इज अ क्विक रिएक्शन, बट there is a little change in the product which is oxide, not hydroxide over there. So this is actually magnesium when reacts with water, and when reacts with steam, right? So this is the difference between water and steam over here in magnesium. You need to keep remember this, right? Then if you talk about the observation of this, so it's very simple. You can write the observation by the product. One of the product over here is gaseous. So you go simple say that colorless gas phases. Colorless gas phases. Colorless gas phases. All right, Bichu. Then if you talk about a reaction with halogens, so reaction with halogens. Talk about reaction with halogens. So it is a very simple equation you can write. I think it is very simple. Magnesium is going to react with any halogen. It is going to form magnesium chloride, right? Because chlorine is from group number 7 and magnesium is from group number 2. So the numbers are different. So they are going to be cross multiplied to give the molecular formula or the formula of the compound. So over here, when magnesium reacts with chlorine, it will give you magnesium chloride. And again, magnesium chloride is a white solid. So you can write observation over here, white solid forms. White solid form. Is that right, Bachu? Now, let's talk about magnesium oxide. If you talk about magnesium oxide, so this is again an ionic compound. So it is also giant ionic lattice. This is giant ionic lattice, right? This is also ionic compound. So this is giant ionic lattice, right? And if you talk about MgO, so it is slightly soluble in water. It is slightly soluble in water to give magnesium hydroxide. So magnesium oxide is slightly soluble in water to give you magnesium hydroxide. You need to keep remember this. This is a slightly soluble substance in water, right? And if you talk about the pH of this, so this is actually having pH almost near to 9. This is a weak base, right? And it can also react with acid as well. If you want to write the reaction with acid, so it will be magnesium oxide. When reacts with HCl, it will give you what? Magnesium chloride plus water, right? So it can even react with acid because it is basic in nature, right? If you talk about the magnesium chloride, so magnesium chloride is what? Magnesium chloride, again, this is giant ionic lattice because it is also an ionic compound. Giant ionic lattice because this is an ionic compound, right? And you can say that magnesium, if you dissolve magnesium chloride into the water, so it is also going to dissociate into the water, right? And the pH is almost 6.5 or somewhere like that, because it is slightly acidic in nature and the solution is actually colorless. Is that right, Bachchu? Is that right, Bachchu?
Yes, sir.
Okay, now let's talk about अल्मोनियम, which is more important over here. सबसे ज्यादा important अगर आपके पास कोई हो सकता है तो यहाँ पर अल्मोनियम हो सकता है. तो let's talk about अल्मोनियम over here. Right, so this is the third element over here in the third period of the periodic table, aluminum. Yeah, aluminum, right? Right. So first of all, we need to react it with water. It is slightly less reactive than sodium and magnesium, so it can react with steam, right? So you can say that reaction with steam, reaction with steam, or it can even react with water, but the reaction will be slow, right? So it will be aluminum reacting with water, aluminum reacting with water to give you aluminum oxide plus hydrogen gas. Right, and for the balancing, you can write 2 over here and 3 over here, right, and 3 over here. So this is a reaction. You can say that aluminum with water will be, you can say that the slow reaction, and even with steam, it is also a slow reaction. Why? Because aluminum always reactive, so it can react with the oxygen present in the atmosphere, right, and from a layer of aluminum oxide onto it, right? So if you want to react it with a good rate, so you need to actually remove the layer from aluminum, right? So you can say that initially the reaction is slow. Initially, the reaction is slow as aluminum has a layer of its oxide on it, right? But the rate of the reaction will be increased as it removes, right? Right? You can say that which would increase as reaction proceeds. As reaction proceed, right? This is actually a reaction of oxygen with aluminum. Oh, sorry, reaction of steam with aluminum, right? Then we have a second reaction, which is actually reaction with oxygen. Reaction with oxygen, right? When you talk about reaction with oxygen, bacho, so it is very simple. When you burn aluminum in the presence of oxygen, it is also going to form oxide of aluminum, right? As sodium is doing, as magnesium is doing, and now this is aluminum doing the same process, right? So you can write 2 over here for the balancing, right? Why we are writing 2 over here? So it will be odd number, 2, 3 is 6, and right, we can write 3 over 3 to the 6 and 4 over here. It is now balanced, right? If you talk about this, so again, aluminum only burn in oxygen if it is powder. Otherwise, protective layer of oxide prevents the reaction, right? You need to keep remember this. If you want to burn aluminum, so you need to use this in the powder form for the burning process, as the aluminum layer is actually causing problem over here, because aluminum oxide will be on the aluminum. For example, if you're taking aluminum rod to burn or aluminum foil to burn, so it will have what? A layer of aluminum oxide onto it, like this. This is a layer of aluminum oxide. And aluminum oxide is a very strong or stable ionic compound, and its melting point is very high, so it's very difficult to burn in the presence of aluminum oxide. So if you break it down into the pieces, definitely inner components of the aluminum metal will be purely aluminum metal, so it can burn easily and the reaction will be good, right? So you can say that if you want to burn aluminum, so you need to use the powder aluminum, right? Then we have a reaction with halogens, or you can even simple write reaction with fluorine, whatever you want to write, but the reaction will remain same, right? When you do this, but so the reaction will be aluminum reacting with chlorine will give you aluminum chloride, right? And for the balancing, I'm writing 2 over here, so it will be even number. We can write 3 over here and 2 over here. Is that right, Bacho? The color of aluminum chloride is yellow, so it can be a observation over here. Can be one of the observation over here. So you can say that observation will be yellow aluminum chloride formed. Yellow aluminum chloride produced. All right, Bicho. Now let's talk about aluminum oxide. If you talk about aluminum oxide, Bicho, so this is a very important formula of a compound which need to be discussed. This is very consistent in exam questions. So you need to remember this. This is one of the giant ionic lattice. This is one of the giant ionic lattice, right? This is one of the giant ionic lattice, and it is insoluble in water. I told you that only sodium and potassium oxide of metal are soluble, well soluble in water, and calcium and magnesium oxide are slightly soluble. A very few part of this, or you can say that very slight soluble in water, and the rest of all are insoluble. So insoluble in water. It will not dissolve in water, and the nature is actually amphoteric. This is very important thing, amphoteric. This is not basic, this is not acidic, this is amphoteric. Amphoteric means it can react with acid and base. Both of them are going to react with aluminum oxide. So if you react aluminum oxide with the like acid, so it will react it with acid and form salt and water, AlCl3 and water. If you want to balance this, just write over here 2 raised to the 6 and 6 over here. It is going to be balanced, and the 3 over here also. All right. So you can write over here the reaction of aluminum oxide with HCl. It is very important, and it can even react with base as well, sodium hydroxide. When it react aluminum oxide with a base, it will form a complex. It will form a complex, and the complex will be like a sodium aluminum hydroxide. Sodium aluminum hydroxide, and for this you require the water molecule as well. So this will be the balanced equation for the reaction of aluminum oxide with sodium hydroxide, right? Is that right? It can react with acid and base, both of them, right? Then we have one more thing to discuss over here, which is ammonium chloride. Ammonium chloride is a very important thing to talk about. It is actually simple molecular structure. It is actually simple molecular structure. That is why it is very important to talk about simple molecular structure. And in exam, it is very consistent about questions. If you talk about ammonium chloride, so it will be like this. At aluminum have 3 electrons in the outermost shell, and they are reacting with chlorine to form aluminum trichloride, like this, right? But still you can see this, that aluminum having 6 electrons in the outermost shell, and 2 electrons are even not there over in aluminum chloride. That is why it is not completed. So what is going to be happen over there in this, the one more thing is going to be happen over here, that one more molecule around this, like over here aluminum chloride, like this. For example, we have aluminum chloride like this in the same container. So you will find one more thing over here is that the lone pair of this chlorine will be donated to the aluminum, and the lone pair of this chlorine will be donated to the aluminum. In this way, it will form Al2Cl6, which is a very consistent question in the exam, and this is actually dative covalent bond. This is actually dative covalent bond or dative bond when one-sided shedding is going to be happen over there. So it is very important to discuss about aluminum chloride. Ammonium chloride is actually simple molecular structure. This is actually simple molecular structure, right? And it can exist as Al2Cl6 as well. So you can say that ammonium chloride dissolve in water to give highly acidic solution as well. You need to keep remember this as well. Ammonium chloride is soluble in water. It is soluble in water and give you can say that highly acidic solution and give highly acidic solution, and the pH is 1. You can understand this, that how acidic the solution is. For example, if you dissolve AlCl3 in water, if you dissolve AlCl3 into the water, you will find this complex over here, like Al and complex with 6 water molecules, charges 3 plus and also 3 chloride negatives over there, right? Is that right, Bacho?
Yes, sir.
Further dissolve this, so it will form what? It will form ammonium hydroxide plus HCl as well. That is why it is highly acidic. That is why it is highly acidic. So it is also one of the very important element, and the compounds of this are also very important to discuss, right? So you need to learn these for your exams, right? Is that right, Bacho? Now we have the fourth one, which is actually silicon. The fourth one is we have silicon. If you talk about silicon, this is the fourth member of period 3. So it can also react with water. If you talk about reaction with water, so it can react with water. When it reacts with water, okay, just wait for the answer. Okay, so we were talking about silicon, right? So let's discuss about silicon. If you react silicon with water, so it can form what? It can form silicon dioxide plus hydrogen gas. It can form silicon dioxide plus hydrogen gas, but you need to keep remember this, that silicon reacts with steam and at very high temperature, right? The only possibility for this reaction is reaction with steel at high temperature, right? So this can be happen over there in these conditions, right? Then if you talk about reaction with oxygen, so it is actually the burning of silicon. So when you are going to burn silicon in the presence of oxygen, so definitely silicon can burn to form silicon dioxide, right? And it is only possible when you heat it strong. When you heat it strong, right? Otherwise, it is also not possible because silicon is a giant structure, right? And then if you talk about a reaction with chlorine or reaction with halogen, we can write a reaction with chlorine over here. If we reacted with chlorine, so silicon can react with 2 molecules of chlorine to form SiCl4. SiCl4, which is actually colorless liquid. Right, this is colorless liquid. Right, so this is what you need to understand. You need to remember. If you talk about silicon dioxide, if you talk about silicon dioxide, so silicon dioxide is actually giant covalent structure. Is actually giant covalent structure. It will be like this, that this silicon is bonded with, for example, this is for example हम इसको बना लेते हैं, for example इस तरह से, ये आपके पास सिलिकॉन है, right? This is like silicon. So this silicon can react with 4 oxygens like this, right? This silicon is actually reacting or attached with 4 oxygens, right? And then every oxygen is going to connect with silicon. So this will be connected, this will be connected, this will be connected with silicon, right? Like this. And again, every silicon is forming 4 different connections with oxygens like this. And again, every oxygen is connected with silicons, right? So this will be like this, right, Bacho? So this is actually giant covalent structure. This is actually giant covalent structure, and in the end, the simplest ratio between the elements connection is SiO2. SiO2 will be the final result, or you can say that every silicon is in average formula. Every silicon is attached with 2 oxygens, right? So you can say that this is actually giant molecular lattice. You can say that this is giant molecular lattice, right? And it cannot dissolve in water, insoluble in water. We know that sand is insoluble in water. It is actually insoluble in water, right? And if you talk about nature, so sand is actually acidic in nature, right? So you can even write over here this one as well. And as it is acidic, so it can react with metal oxide, right? Can react with bases or metal oxide. So silicon dioxide can react with calcium oxide to form calcium silicate, which is known as slag, right? So you need to remember this as well. And then if you talk about the reaction with alkalis or water, you can even react it with simple alkali as well, or aqueous alkali as well. So it will be like silicon dioxide is acidic in nature. So you can use aqueous sodium hydroxide to react. When it reacts with this, it will give you salt and water, right? And one more important one is silicon tetrachloride over here, which is also very important. It is very simple molecule, right? So this actually simple molecular structure. This is not giant. This is simple molecular because it has only covalent bonds, right? It is actually silicon, 4 bonds with 4 hydrogens. That's all. So this is a simple molecular structure, right? So SiCl4 can dissolve in water to give like it will be acidic in nature, now. So you can say that silicon tetrachloride is soluble in water and give acidic solution, right? It is soluble in water to give acidic solution, right? So when you talk about SiCl4, so SiCl4 will dissolve in water, right, to give you SiO2 plus 4HCl. That is why it is giving you acidic pH, right? Or you can say that fumes of or white fumes of HCl. Or you need to keep remember whenever you talk about fumes of HCl, they are like steamy fumes. You can say that steamy fumes of HCl form over there in this reaction. So this is also one of the very, very important reaction to remember. Okay, bacho, is that clear about silicon? Is that right, bacho?
Yes, sir.
चले तो आपको ये सारी चीजें पता होनी चाहिए बच्चों. अभी फिलहाल हमने इन 4 की बात की है, तो ये 4 आपको पता होना चाहिए. फर्स्ट ऑफ ऑल यू नीड टू टॉक अबाउट सोडियम. सोडियम की सारी बातें आपको पता होनी चाहिए. सोडियम ऑक्साइड के बारे में, सोडियम क्लोराइड के बारे में, उनके रिएक्शंस ये फिर भी इतने इंपॉर्टेंट नहीं है. और मैग्नीशियम के बारे में आपको पता होना चाहिए, याद होना चाहिए. ये चलें फिर भी अगर हम इसको सपोज करें, चलें बहुत कम इंपॉर्टेंट है. लेकिन ये वाला जो आपके पास है सिलिकॉन वाला, ये सबसे ज्यादा इंपॉर्टेंट होने वाला है. एल्युमिनियम ऑक्साइड के रिएक्शंस पेपर में बहुत आते हैं. एल्युमिनियम क्लोराइड के बारे में आपको पता होना चाहिए. Al2Cl6 के बारे में आपको पता होना चाहिए. इट इज वेरी इंपॉर्टेंट. एल्युमिनियम ऑक्साइड की नेचर वगैरह के बारे में आपको पता होना चाहिए. ये पेपर में बहुत ज्यादा आता है. और उसके बाद फिर सिलिकॉन इज ऑल्सो वेरी वेरी इंपॉर्टेंट। तो पहली फुर्सत में इन सारी चीजों को आप याद कर लें। These are very very important and they can be asked for multiple marks in separate different questions, right बच्चों? Is that clear? And we'll talk about the remaining three elements in the next class inshallah.